Open a shell inside a running container and look around. List the processes, you only see its own. Check the host name, it has its own. List the file system, its own, top to bottom. From the inside, this thing is utterly convinced it's a whole separate computer. But here's the truth. It's actually just one ordinary process on your laptop, wearing a blindfold. That's what a container really is, and today we explain it with a sealed cargo box. Welcome to Docker Explained, Video 3. Stick around for stop 4. Most people are sure there's a tiny computer running in there. There isn't. 6 stops, all inside the box. First, the walls, what the box can see. Second, the stamp, what the box can use. Stop 3, the myth, that a container is a tiny computer. Stop 4 is locked. It's the real answer and the aha of this whole video. Stop 5, the cheat sheet, sealed box mapped to container. And stop 6, the bonus, where we prove a container is just one process. Live, one analogy throughout, a sealed cargo box on a shared ship. Stop 4 stays locked until we've earned it. Last time we learned that all the boxes share the ship's one engine, the host kernel. Nothing is duplicated, but that raises a puzzle. If every box sits on the same ship, sharing the same engine, the same machine, why can't one box see into another one's cargo? Why does each one feel completely alone? Answering that is the heart of today. Picture a sealed cargo box, opaque steel walls, no windows. From the outside, on the deck, it's just one labeled box. One box among hundreds, nothing special about it. But from inside that box, you can't see any of the others. As far as you're concerned, you got the whole ship to yourself. Same box, two completely different points of view, and that gap is the entire secret of a container. Stop 1, the walls, what the box can see. Inside, the container sees its own process list and nobody else's. Its own network and address. Its own file system, from root to tip. Here's the real word for those walls, namespaces. A namespace is Linux handing a process a private view of the system, its own little world. And this is the crucial part. The deck isn't empty around it. There are dozens of other boxes right there. The container just can't see past its own walls. Here's a concrete example of those walls in action. Inside the box, your app is process number 1, PID 1. It looks like it just booted a brand new machine, and it's the first thing running. But out on the host, that exact same app is key ID 5829, just one of hundreds of processes your laptop is juggling. Same process, 2 different numbers, 2 viewpoints. That's the blindfold doing its job, the namespace renumbering the world so the container thinks it's alone. Quick prediction, the walls control what a box can see, but what about when it can take? Suppose one greedy box tries to hog all the CPU on the ship. What happens to every other box sharing it? Think about it before we reveal the second half of the trick. Stop 2, the stamp, what the box can use. Every box wears a stamped limit on the side, a maximum weight and size. For a container, that's a cap on CPU and a cap on memory. So a greedy box can't sink the ship, it hits its own ceiling and gets stopped, while every other box sails on untouched. The real word for that stamp is key groups, control groups, Linux capping the resources a process is allowed to use. So now you've got both halves. Namespaces are what the box can see, cgroups are what the box can use. Put the two together, and you've fully defined a container. The walls are namespaces, a private view with its own processes, network, and file system. The stamp is groups, a hard limit on CPU and memory. And that's the entire thing. A container is a normal process plus walls plus a stamp. Nothing more is hiding in there. And remember where all this is happening. The box runs on the ship's one engine, the host kernel from last video. It never packed an engine of its own. That's why there's nothing to boot and nothing being emulated. It's just a fenced-off process running directly on the host. Hold on to that. It's about to bust the biggest myth about containers. Here's the lock stop, number 4. With its own processes, its own network, its own file system, surely there's a tiny computer running inside that box? It really feels like there is. Hold your answer. So let's settle it. The myth, it has its own processes, its own files, its own network. So there must be a little machine running in there. The reality, there isn't. A container is an ordinary process on your host, fenced off by exactly two Linux features. Namespaces, what it can see, and cgroups, what it can use. Nothing is emulated, nothing is booted, no second operating system exists. That unlocks stop 4. A container is a process, fenced and capped, not a machine. Here's your decoder ring for what's really going on inside the box. The opaque walls are namespaces, what it can see. The stamped limit is cgroups, what it can use. The ship's engine is the shared host kernel. And the fact that your app is process number 1 inside, that's PID 1 within its own namespace. Pause and screenshot this. It's the anatomy of a container. Let's prove it. Inside the box, we run Cs, and there's our app, nodeserver.js, sitting at PID 1. Now, at the very same moment, let's look out on the host. We run C on the host, and there's the exact same process, nodeserver.js, at PID 50829. Then Docker top shows the mapping directly. PID 1 inside is PID 5829 outside. One process, two PIDs. That's hard proof it's not a separate machine. It's your host process wearing a blindfold. What did that prove? 3 things. The container's PID 1 is just a renumbered host process. Same process, friendlier number. The box is a view, not a machine. Docker changed what the process can see, not the hardware it runs on. And you can kill it from the host like any normal process, and the box simply vanishes. No VM, no emulation. A container is a process wearing a blindfold and a weight limit. That's the whole story. So here's the entire video in one line. Take an ordinary process. Put walls around it, namespaces, so it sees only its own world. Stamp a limit on it, cgroups, so it can only use so much. That's a container, just a process, fenced off and capped. Once you see it that way, Docker stops being magic. Challenge before you go, a container is just a process. So what do you think happens to the files inside it when it stops? Drop your guess in the comments. We settle it for good in a couple of videos. Next up, we've been talking about the box, but where does the box come from? What's the template it's stamped from? That's images versus containers, explained with the mold and the boxes it stamps. See you on the dock.